This is my GSX's BFH. It's the original second generation viscous limited slip rear differential, and it's gone about 150,000 miles with nothing other than fluid changes. The fluid that's in it right now is shockproof heavy that's less than 500 miles old. And you watch me put it in there if you've been here since the beginning. But it sat for 12 years after that, making it do some really weird stuff. Either way, it doesn't want to come out of there, and everyone who's fished around inside of something that's used it knows exactly what I'm talking about here, that even after you've drained it, no matter what, you're still going to find more. Solvents don't thin it very well. This stuff is thick, and it's not exactly what you should be running in a street car. This is for drag usage. Did all this stuff already to a 1G diff though. You saw the gallant happen, and the service parts for this are the same, but the casting and mounting's different. Just like the other one, this is a manual 3.545 gear ratio viscous limited slip rear differential. It's just a newer generation of it. No different than the gallant. I plan to make its aesthetics match everything else I've already got going on under there. I'm just going to lightly brush all this oxidation and these salts away with my Dremel to brighten it up a bit, and there's a whole lot of crust in this thing, man. I'm totally not going to end up buffing the living daylights out of it with black rouge on the polisher for the next 5 hours. Nah, just, an easy wire wheeling and wipe it off. Yeah, there you go. I know nothing of what I might find. It worked fine before I took it all apart. This is exploratory. First thing I want to check is the backlash. Spec is 4.5 to 6 thousandths. I'm just using a dial gauge centered off the far edge of the tooth and measuring how much slop there is between the gears. And I can tell you right now that I'm not very happy with what I'm seeing. I'm at 8 thousandths, and you're supposed to measure it in several spots to make sure it's consistent. And it is. It's consistently bad. There's a spot where I'm measuring 9, so we're between 2 and 3 thousandths over the backlash specification already, and we're just getting started. I'd say that its current day condition is consistent with its past usage. That ring and pinion might be toast. What to do about that? Well, I can just grab this here BFB, which is second generation open differential out of a non-limited slip manual transmission DSM. It's got the same case, ring, and pinion gear on it. I don't know anything about it other than it came from a car with less miles that's gone a whole lot faster than mine, but only briefly before being swapped to an automatic. I'm going to do the same exact test to this one and see what I get. I don't believe my eyes right now. Ladies and gentlemen, hold on to your giblets. It's a used all-wheel drive DSM rear differential that's at the very beginning of its backlash specification in 2024. That really did just happen. It's almost a shame to take this one apart, except for no, it's not. Most people would have just passed this one by. Because just like those other people, it doesn't have the differential that I really want inside it either. But there's hidden gems in these BFBs. The cases are identical. So are the ring and pinion gears, the bearings, the seals, the plugs, the bolts, the works. Only the differentials differ. Yeah, I said it. The Gallant left me using very little of my parts stash because it was already perfect on the inside. So I still have everything necessary to rebuild another one. So here's my thinking. Just swap these differentials into each other's cases, but swap the ring gears too, so that everything else meshes right and stays together. The ring and pinions get to stay mated in their original cases and to their original pinion gear. Then I'm going to see what I've got. I know this one's got a perfectly worn ring and pinion. It's at the beginning of its spec, so its wear pattern's perfect. If I manage to match that spec with a limited slip unit in it, then afterwards I'm golden. Suddenly it becomes a beginning of spec limited slip unit. And I should be able to do that if I can get my shims right, or if Mitsubishi's machining tolerances are close enough and I get lucky, then maybe just with the ones I've got I can pull this off. I don't know, we'll see. But that's what I'm going to try to do here with them. If you watch me take apart the Gallant differential, I'm not doing this one the way the service manual says to do it. Not this time. I destroyed 2 perfectly good hammer handles doing that, and that method is retarded. But if you remember the turnbuckles that I used in the aluminum subframe bushing install video, I'm just going to use them as a makeshift case spreader for the carrier housing. If you heard my voiceover in that Gallant video, I suggested this case spreader thing while doing it the way the manual said. I even tried searching this topic, and nobody in the DSM circles is talking about it, but they should be. They will now. It's an interference fit, so spreading the case out makes it let go. Probably the worst part of setting up the rear diff the way the service manual says to is installing and removing the rear diff for as many times as necessary in order to get the dang thing shimmed correctly. To get it perfect, you have to do it a lot. Measure a whole lot of things and do it again and again. I got lucky with the Gallant, really lucky for a car that old. All it needed was seals. I only used the service manual recommended method that once, and I'll never do it again. So even if you don't need to straighten out your subframe, go down to your hardware store and get yourself a set of turnbuckles for occasions like these. It makes short work of jobs like that. If you want to be proficient at getting everything correct and set up as true as possible, then you're going to need to have an efficient way similar to this at your disposal to get everything in and out without destroying it, including your hammer. Seriously. 2 bolts and you got yourself a $10 turnbuckle case spreader. That was a whole lot easier than the last video. I'm pretty sure I can do that without bumping it against the table too. First time I've ever tried it, but it's great that I got that ring gear donor out that easily. I keep the caps in order by stacking them the way they came out and bolting them right back in when I'm finished. So I got the ring and pinion donor apart. Now let's get the good part of that BFH out of there. I got this idea from the Jeep community who messes with Dana rears, and they make beefy case spreaders for this purpose. Some manufacturers offer application-specific specialty tools that do stuff like this for specific jobs on cars, but it doesn't take that much investment to do the exact same thing with the DSM differentials I'm demonstrating. No bumps. I just did that with my fingertips. It doesn't take much to install and remove the gear housing from the carrier like this. The Shim set preload on the tapered roller bearings based off of a specific amount of case deflection. So once you relieve that, it slides out without a fight. The casting is just flexible enough. That trick should take the fear out of hammer handles everywhere. Thank you, Service Manual, for making me to have to be the one to say something about it. I can't even patent and sell you a tool now. So now I've got 2 differentials that I need to swap the ring gears on. The wear of the bearings are now specific to both parts, so before I go buck wild with the impacts, I'm going to stack and arrange both sets of the shims and bearing races inside the carrier housings that these differentials came from. As a rule, I always stack them fat side of the differential down, because that's how I always take them apart. But I'm going to need the race from the skinny side because the ring gear, taking that off doesn't have to be complicated either. I just need to be able to spin this thing. The ring gear can be a tight fit and it can get stuck on there. It can also get glued on there by the thread locker it's assembled with. So once again, rather than beating on anything, I'm going to show you the best 2 non-destructive methods for separating it. After you blasted all the bolts off with an impact, next you grab a torch and a propane one will do just fine for stuff like this. So many people tell me I sound like Hank Hill that I feel obligated to talk to you about propane and propane. Hey! See, it doesn't take very long. It's fun. I think Hank's onto something. The other easy method really looks an awful lot like the first one until you see it. I'm not talking about the air hose constantly blowing off my impact wrench either. It's infuriating. The one that doesn't need fire is called getting lucky. Oh, it just falls right off. That's how it wants to be. Either way, try your best not to beat on the ring gear. I'm going to give this differential a better mineral spirits bath now that it's out of the case and I can get to everything all at once. Like I said about that heavyweight shockproof, you're going to continue finding more and more of it. It's just super sticky stuff and I want it gone. My plan is just to leave the bearings on the differentials for now and see what I've got for starters. Backlash is the primary problem that I have to fix, so until I get that close to spec again, I'm not going to focus too much on the other tests. I will do some basic inspections when introducing new parts, but you can learn a lot about their condition just from a Backlash test. The tolerances of these parts are very precise. If I had to separate a ring gear from a differential and I wasn't replacing either part, then I would mark its orientation. More specifically though, I would scribe that mark because it's not going to survive the cleaning. But here I don't get to do that. Though the machining tolerances are precise, even a new ring gear won't fit like the one you just wore out, so if the ring gear is new to the differential, your inspection needs to be very thorough as you progress through its installation. If I can get the Backlash in spec, that's when runout begins to matter the most. That's when I get to refocus my efforts back onto the fit of the ring gear. Right now my only responsibility is cleaning out all the old thread sealant and ensuring that the flange surfaces are free of any and all foreign material because anything trapped beneath these surfaces will affect all of my future tests. But the odds on an 8-bolt flange mean that I have a 12.5% chance that it's in the best spot the first time that I did it. That's how this one's going to have to be. It's in a powerful display of confidence that the odds are in my favor. I'm already applying thread locker to the bolts again. I'm that certain. No air tools here, no impacts. This is going to be one of those manual jobs. Run the bolts all the way down until they're almost snug. The service manual says to clamp the differential into a vise, and I'm certain it's going to leave a mark. My insistence on not leaving a mark ensures that the vise has no grip once I start getting higher up into the torque range. You want to install these bolts gradually up to spec in an opposing star sequence, much like you would with an 8-lug wheel. Work your way around it until you reach between 58 and 65 foot-pounds on every single bolt. Whatever number you hit, just make sure you do your best to match it on all of them. If you torque them unevenly, you can create distortion in the ring gear just like you can if you torque them in the wrong order. So I've got the diff, the bearings, the races, and the shims all cleaned up from the BFH, and I'm just going to get these BFB bearings and races out of here. The shims I'm using are the ones that centered the BFH differential in the BFH carrier housing. I'm banking on my carrier housings sharing the same physical machining dimensions, and that if that's the case, my shims are going to be responsible for aligning the nuances of each differential. I mean, why shouldn't it work that way, right? I imagine. Banking that all of this is going to go smoothly the first time, I'm going to go ahead and mark the gears. I found that Dicam was, it showed brush strokes and it was a little bit too durable to wear off for a good read. I don't have a Sharpie handy that can survive this kind of coverage, so I'm just going to try something different. I've got an ample supply of dry erase markers. I can still leave streaks doing it this way, but it does seem to cover a whole lot thinner and evenly and easily, really. Just you don't get the convenience of a liquid and a brush to work with quickly. But it definitely looks like something I'll be able to work with more easily, so I'm going to do it this way. I'm going to go ahead and get this other ring gear out of the way here real quick too. Lube up the bearings with some Lucas oil for a little protection while we do this test fit, and gauge where we're at on the backlash. I always work with the fat side of the diff facing down, remember? Set this whole stack in there. Now grab the old turnbuckle thingy and the bolts, put those things on there. Get it all snug as far as you can by hand, and then give it one complete rotation with a wrench, and now try to see if you can wiggle it into place. Or see if you can wiggle it when you should have waggled it, and now you've got it all stuck in there cockeyed. Give that thing another turn. Man, I got this thing stuck good. So now I'm going to give it the old thumbs through the ear holes and bump it on the workbench. And again. And one for good luck. Okay, freeze! Don't do this. Don't ever do this. Do it the way I show you the next time. You can continue now. That had a good sound to it. I was 100% positive this was going to work before I tried it. You saw me. You were there. But I'm still going to make sure the shims made it all the way in there with the brass punch. Happy with that, I'm taking off the turnbuckle, attaching the carrier caps, and torquing all 4 of the bolts to 36 foot-pounds. Your torque sequence doesn't matter at all here. Just make sure that all the bolts are evenly torqued. Now, I'm going to go ahead and check the pinion gear position on the ring gear. And this is the thing I'm doing the way the service manual says to do it. I'm just grinding away a little bit more of my brass punch against the case, going one way and then the other with it. And honestly, it really doesn't look too bad at first glance. It's meshed evenly on the center line towards the outer third of the tooth. Goes pretty deep down in the teeth. I like this. And what in the wide, wide world of sports is going on here? Why did my problem move with the diff on a brand new ring gear? I'm at 8 thousandths again. Let me measure somewhere else. Yeah, 8 thousandths. Well, that's more like 7.8. Still. Okay, one last time. Got to check somewhere completely different. Why is this one 6? That doesn't make sense, does it? Really? Wait a minute, I don't have it on the right part of the gear. Let me try that again. Yeah, 7. Still, I've got a variation of 1,000th, which isn't too bad. I can probably work with that. But it's almost like I moved my backlash problem with me. Measuring the BFH shims, I've got 2.7 millimeters. This one was on the bottom. 2.68 is on the top. What's this thin one over here from the BFB? Looks like 2.33 millimeters. And the fat BFB one comes out at 2.91 millimeters. So the fat one's about 0.2 of a millimeter thicker than the shims on the BFH. For the standard measurement nerds out there, that's 115 thousandths on the fat one. We've got 106 thousandths on the bottom one, 105 thousandths on the top one, and the skinny one over here rings in at 92 thousandths. After a quick measurement of the shims I just used, to make sure I got them in the right order, I used the thinnest shim from the BFH with the thickest side from the BFB. I know that they're both practically the same thickness and that doing this is wrong, but I just want to see how far the backlash moves with that thick shim on the bottom. And wouldn't you know it, these shims combined are so thick that I can't even get the dang diff back in there. Let's try the thick spacer and the thin one from the BFB together. The original BFB shims. And notice I don't even have the case spreader on there yet. That should not have fit like that. That's because the shims came with the BFB, or they're too thin for this setup. That means the dimensions of either the differential housing and or the diff carrier are a little bit different. I'm going to be too limited with the shims that I have here because now this thing is going to have to be set up from scratch. Side bearing load is set by case deflection from the interference fit. That's the reason why I use the case spreader to quickly and easily do this job. But however hard that squeeze is affects your bearing life, so there's a right and wrong way to do it. But for now, I'm just doing it the wrong way because I'm determined to know how much backlash moves with that thick spacer on the bottom. So here we go. I'm going to overload it with the thin BFH shim again and go for round 2. If you end up bending your bolts with the turnbuckle, just trying to put the diff in there, then you're using the wrong shims because it's only about 4 thousandths or a half millimeter of crush that you're trying to achieve on those bearings. But let's see what this one measures up to. And I got my answer. That thing's buried. I'm not even 4 thousandths. It's way too tight. And there's way too much bearing crush going on here. I ordered a shim set, and I don't know why I didn't do that back when I bought everything else, because it would be here right now, but it'll be a little while before I see it, and in the meantime, I put this thing back together with the original BFH shims to scrutinize something that I noticed happening once I was finished doing all this work. I was getting different backlash measurements in different spots that were more erratic than they were in my initial tests, so I wrote them around the face of the gear, and on my second pass to verify them in the same spots, I got different measurements again. That tells me I have a problem with the side roller bearings on the diff. It could be a problem that they already had, and it could be something that I just caused, along the way here with my test. Either way, if I've got to reshim and set this one up from scratch, I might as well replace the carrier side bearings that I do have. Look at this. Yes, I caused this. When you're installing and removing the bearings, it's very important not to let the outer races shift or get cockeyed while it's going in there. You have to keep them flat up against the rollers the entire time. I know this is my fault now because these gouges are on the top side of one side of the race and the bottom side of the other. I wasn't careful enough trying to put this back in here with the shims that were way too thick. The bearing race material is much softer than the bearings. This is my fault. Don't do what I did. Keep them flush on the race when you're installing the diff. So if you're like me and you have to replace your bearings, it might be nice to have a complete set of Mitsubishi service tools. The jury's still out on that one. I grabbed the new bearings from my parts hoard, and we're going to be doing some fun stuff with a heat gun over there soon. It's frustrating, man. I have 75% of the tool necessary for installing and removing these carrier side bearings here, and I've got, this could have been this tool's big debut, but there's a piece missing that I've been looking for forever. I have no idea if I'm ever going to find it. This right here fits on the inside. It's one of these pieces that can secure itself against the bearing you see right there. It's got the right taper on it for these tapered roller bearings. And this is a tool that's designed to grab underneath the outer race. And there's supposed to be a clamp that goes around this thing that fastens and contains this and pulls it all together so that you can plunge this thing down in it and pull the bearing out. So because I don't have all the pieces, we have to find alternative methods of using all these tools together. Or maybe I won't. Maybe I'll just grab a bunch of sockets and a bearing splitter, clamp the splitter under the bearing, and press it off the conventional way. Of course, you can't care about saving the bearing this way, but that's rarely what anyone's ever trying to do when they press them off like this. There's really nothing quite like the sensation of collecting all these rare Mitsubishi service tools for an entire decade and still coming up short having what you need when the time comes. That tool could do this a much softer, gentler way. It's both a puller and an installer. It's used extensively for transmission work too. I didn't lose the clamp thing, I've just never found these together as a set, and that clamp is always the piece that's missing. got it. Because the specialty tool is incomplete, I plan to use the thermal advantage and heat my tools up as hot as I can get them, because these are going to be the ones that are touching the bearings. And I've got a differential that I froze 5 hours ago in the freezer right now, and that thing's probably cooked. So I think what I'm going to do here is cook these the other way and see if I can get a thermal advantage so I can install this without any hammers or any beating on them. I want to take as good a care of this bearing as I possibly can. This is something you've seen me do several times in different ways. This is not a bushing. I'm not busting out the dry ice this time, but I'm going to get it really hot. You can usually achieve the temperature differential with just a freezer and a heat gun for this kind of work on bearings. You need a temperature differential of hundreds of degrees, not just 100. To achieve that, I've sandwiched the bearing between a few of my specialty tools to encase it inside the hot air stream. And I took this well above the boiling point. I've got the inside of this thing between 300 and 400 degrees now. Let's grab that diff. I froze another piece of steel to set it on while we work. So I shrunk the diff and I grew the bearing. Let's give that bearing a shot. That was super satisfying, wasn't it? Notice the welding gloves? Those are kind of important too. Don't let the frost on the diff fool you into thinking that you won't burn yourself. You totally will. If you were smart, you'd put the diff right back in the freezer again so you can take your time heating up the other bearing. The bearing won't fit on there like the other one without the vigorous heat gun process first. And I wasn't anywhere near as aggressive with the heat gun as I should have been this time. I'm rushing myself actually because I know that diff is coming up quick temperature-wise, and exactly as I feared, I wound up getting the dang thing stuck halfway on there. Fortunately for me, there's a specialty tool that I do have that's stepped to dodge the bearing cage. It has a protrusion that presses on the inner race only. At least I had the specialty tool that didn't send me searching for the right size socket to fit this thing. That was nice. Felt kind of good. Let that thing thaw because your tests are useless until it's all at the same temperature as everything else. And you know, while I was waiting, I got to thinking, and that's not always a good thing, but I was all like, I bet that Gallant VR4 3-bolt disc got some shims all up in it. And you know what? It totally did. The B2B Gallant VR4 3-bolt rear diff is no match for a 14mm impact 2 bolts and a turnbuckle. I did that in 3 minutes and be able to prove it if the memory card were in the camera instead of my pocket. The B2B is an open diff just like the BFB is. It's just this 1G version of the open diff. There's the rear power steering pump drive gear for all of you who've never seen it before, and there's the shims that I went in there after. Starting with the standard nerds, the skinny one's right here at 98 thousandths, and the fat one is at 109.5 thousandths, or 110, however you want to cut it. For the metric nerds, the thick one is 2.77 mil, and the thin one squeaks by with the 2.49. So these are between the extremes of what I've got so far. I like where this is going. I need some medium ones in the mix, you know. The more important thing is the combined thickness of the shims, because that's really what determines the bearing preload. The set from the B2B is 5.3 millimeters, or 207.5 thousandths. The set from the BFB 2G open diff combined are also 207.5 thousandths. You know, that's a 5.3 millimeters. The set from the BFH, which are nearly identical in thickness independently, they ring in at a whopping 213.5, so 6 thousandths thicker. That could be from the differential or the carrier housing. I think that's something I might be able to figure out with a little more fitting, but I'm a second guess myself. Make sure I'm using the Gallant shims to fit the BFH in here. So the thick shim on this set is thinner than the other one, so let's see if that leaves me a little bit less buried. That is how you do it. That's how it should go together when you're doing it right. If anything binds, you take it right back out. Danger to side bearing races. Don't overload your shims. Borrowing shims out of another differential is not the right way to do any of this. And a lot of why we're doing this right now is because the shim kit's not here yet. I'll show you how to measure for your shims in a minute. This is all the stuff that you try to do without it, and I'm just doing all this on video to save you the trouble. I'm going to save you from the struggle you don't need, but I'll give you tips like this turnbuckle thing to make that struggle easier on you when you do need it. If you were watching closely, those first two measurements looked great, but then you've got spots like these where it rings in at 2.5 thousandths. That's way below spec. And over here it looks like we've got something like 3.5 thousandths. Close, but still below spec. 3.5 here too. Over here we got another spot at 2.5 thou. So this one's close but no cigar. It's a little bit too tight for my liking. You don't want to set up a used ring and pinion together tighter than it previously was operating because it'll stress crack the gear teeth. So even though this one's close, I don't have the shims necessary to nail this one perfectly or even correctly, no matter how many of the differentials I have here to take apart. I've been waiting weeks already for international shipping, but it'll happen. I've proven the concept with the last test and that this carrier housing and diff combo is going to be viable, so now I know the time and expense of powder coating this one is a good investment, and that still needs to be done, so that's what I'm about to prepare for here. Do you like how I put that rag under the pinion shaft to give it a soft landing? It really is in good shape. The edges of the gear teeth look new. What a treat to have this on my car's 30th birthday. It is today. Happy 30th, GSX, but I'm just wrapping that thing up with its old ring gear buddy and giving this thing a bath before it goes out the door because I don't hate Justin. Often bearing races will fall out of castings while they're in the oven. And, they'll survive being baked, but they may not stay seated inside the part. So I'm taking one side of the pinion bearing out and just warning Justin that the inner race is still inside it. That's right, this one's going to detective coating too. You saw how good the Gallant diff turned out. That was the perfect recipe and worth eating again. 2+2 is a parts washer in a can, and it always does a fast job at degreasing everything. I'll have to wait until detective coating's open this time, but, just so I don't forget it, I'll put it with all the other stuff that I was supposed to have coated already that I keep forgetting about. I want my workbench back too, and I promised you earlier that I'd show you how to measure your side bearing clearance, so let's do that, and put the one that I'm not using back together. Grab a set of feeler gauges and you can either add up all the measurements for the stack of feeler gauges you have to use for this, however many it takes to fill the gap and in what order, or just grab your calipers and measure how thick that stack is. You'll need to mash pretty hard because they spread. The parts you're going to shove them in between are pretty stubborn too, so it doesn't hurt if you do it, but it sure saves a whole lot of time and math to just measure it. Press the diff to one side of the case and find the tightest combo of feeler gauges you can fit through on either side between the bearing races and the carrier housings. Now add 4 thousandths of an inch or 0.1 millimeter to your measurement. Divide that result by 2. That makes my median shim measurement 102 thousandths per side. That 4 thousandths or the 0.1 millimeter is for side bearing preload, and you need to get that right because overloading the bearing is going to shorten the life of all the parts inside the differential case. It's 2 thousandths or 0.05 millimeters added to each side. Here my stack of shims is 204.5 thousandths, and you saw me measure 200 thousandths on the feeler gauges a moment ago. So this is the correct shim thickness I need for bearing preload. This one right here on the bottom is the fat one at 106 thousandths, and if you use a shim that's 4 thousandths thicker than your median on one side, then you need one that's 4 thousandths thinner than the median on the other side to maintain your side bearing preload. And that's what I got here. This one's 98 thousandths. The reason why you would use a thicker or a thinner shim, as I've demonstrated earlier in the video, is to reposition the differential closer or further away from the pinion gear. You've found the correct shims once you've managed to settle both the bearing preload and the center line of your differential relative to the pinion gear. This is the purpose of the die test on the gears, to check your work, to make sure that the gears are meshing properly. And the results of those tests are illustrated in the service manual to tell you what to look out for or what's wrong based on the way that ink wears. But by using a backlash test, I don't even need a die test to see that this one's completely wrong. The differential that was in here originally had 2 shims of the exact same thickness when it came out, whereas this differential in a different housing had a pretty extreme offset. I'd use both shims in this case with this differential, except that they're not even thick enough to fill this gap. And this is why it's kind of cool if you can ever get lucky and find the shim you're looking for in a scrap pile. But because of the personal nature of how one differential was going to fit inside of a different carrier housing, you're going to have to start from scratch with the shim kit in order to really get it right. That's just how it is.
And this is what that looks like. Part number right there on the bag. Every shim you might need to do this right is in it. Let me show you. Starting with the first one, it rings in at 1/10 of an inch, which we all know is 2.54 millimeters. Next up, we've got 103 thousandths, 105 thousandths, 107 thousandths. You can see the 2 thousandths increment playing out, 109, all the way up to the biggest one in the pack, which is an eighth of an inch, or 3.16 millimeters. I didn't buy the shim kit for the pinion shaft because I'm not messing with that thing. All that's already set up for the ring gear that I'm using, and just like my bearing driver, I'm also missing one piece of the pinion gauge set. If only I had the case back from Yeah, well, here we've got the rear diff carrier housing and all the other parts from the pile already finished. Dang it, Detective Coating's always right on time. I had this one coated in steel gray. We all know steel's stronger than cast iron, so this one's going to be invincible now. Yeah, that's exactly how this works. They did a much better job than I ever could, a lot faster too, and with a good bit less filth on the inside. Every time you get something powder coated, I'm going to tell you to clean it out really good because you always should. The fallout from that process, whether we're talking about the preparation or the coating, is unavoidable, and you don't want any of that stuff mixed up in your oily bits. The cleaning process I use is simple. Beyond using compressed air to blast out all the loose stuff, the first thing I do is soak it all really well with WD-40. Next, I scrub every corner out, wiping it down with something white that lets me see what's coming out. Yeah, I could have used a coffee filter if I had one. I need to get more. But I'm nowhere near done yet, so the paper towel here isn't going to hurt anything. This penetrates the casting to saturate anything stuck in there real good with all kinds of oil, and it's thinner than what's normally in here. And next, I use mineral spirits, which is a powerful degreaser, to lift out all that WD, get it out of there. In theory, with all that oily stuff that's willing to let go. Next, I dry it with compressed air, which leaves everything clean, dust-free, and drier than a desert. Now this thing's ready to receive all of its spinny bits. But all the spinny bits all need to be cleaned too. You saw me mucking around there with the red rags. We all saw those fuzz balls. Before I get into all that, I've got a bearing race to reinstall from the pinion shaft. I'm doing the thermal advantage thing again. It's in the freezer right now. If you recall, I knocked one out before the powder coat so it wouldn't fall out in the oven. I'm not changing this bearing because for one thing, they're not bad, and for another, the pinion depth and shims are already correct for that ring gear, so I have plenty of incentive not to change it. I don't have a complete pinion gauge set either. Of all the specialty tools that I've ever hunted, it's the rear diff tools that have always been the absolute hardest to find. So today, I'm just using the frozen pinion shaft assembly, and the drive shaft flange is my bearing drivers. With the temperature differential, I can more easily get the race set in the seat because I shrunk it. And using the flange with a ratchet wrench, I can feel if anything binds and then respond to it appropriately so I don't overload anything. I don't feel bad about giving it encouragement with a plastic mallet. It's built to endure way more abuse than this. And as soon as I could feel the bearing bottom out, the nut comes right back off and the shaft comes back out again because I want to check my work. And I still need to clean everything and install the seal. No scoring or bearing prints on that race. It's in there. Didn't hurt anything. Sweet! Now let's clean up these parts and get them ready for their old remodeled home again. Mineral spirits bath to remove anything that dirt can stick to. Finished off by some compressed air. Make sure I get up under and inside all the bits and stack it all back up again. Got that flange real good too. Happy to see it still had all its original paint intact under all that funk. I'm using Lucas oil stabilizer on the bearings to keep them safe until fluids arrive because it's really sticky and it'll do a good job at that. Lube up both the inner and the outer bearings. And oh yeah, I need that seal installed too. That's kind of important. I don't have the correct specialty tool, except yes I do. I have a combo that does the exact same thing that we learned on the Gallant Diff. We learned that the 1G rear axle ABS ring driver is the perfect fit for this. It does a flush seal on the inner lip without touching the outer lip. It's perfect. So now I can just take all these stacked up bits, put the pinion shaft in because everything's already cleaned, lubed, and ready to go. Grease up the splines, and you see I've got the grease out. Yeah, it would have been really helpful if I greased everything that I needed to grease, not just the splines. But oh well. Let me show you why. I ran the nut all the way down, checking the lash of the bearings and creeping up at the near 0 point. Now, I'm not going to do the whole thing with the wrench this time. This is a whole lot easier than doing it the hand tool way. And when I'm close enough, I stop. That's the moment when I get mad at myself, because that squeaking sound is the sound of dry rubber seal on dry metal. I don't really want to smoke that seal in the earliest stages of its life, so it looks like that flange needs to come back off again because I forgot to grease that inner seal boss. This is all on me.
Now put that thing back on like I just did the first time, real fast, and I'm going to put all the other pieces in place and use that new shim kit that just arrived. All that fiddling with the wrong shims earlier wasn't for naught. I found the set that got me close to where I needed to be, and that gave me a baseline for roughly the size of a shim that I'd need to start with once they got here. The one under the ring gear that got me the closest was 110 thousandths. That's the one that gave me 2.5 to 4 thousandths of backlash. So what I'm going to do this time is find the one that's 2 thousandths smaller than that to move it away a tad, and also to get a measurement of the gap on this differential spot on so that I can get my bearing preload correct using the other side. So after all the FA, the FO ends up being 211 thousandths, I think. Pretty sure. I don't know, man. You see me go back and check myself several times. I'm just the guy that has to make all this work. I started out with one at 106 thousandths, figuring the gears cut at a 45 degree, so that should add 2 thousandths to the backlash by splitting it in half. And I came up with a set that rings in at 212 thousandths, which is okay. But I need to add some more to that to hit the right preload, and at 4 thousandths with that measurement, I need to see it around 215 thousandths. I eventually found one that gave me a combo only a half thousandths bigger, so I figure I'll start there. You see it right there, 215.5 thousandths, both shims. Somehow these measurements don't add up though. Their individual measurements don't math with their combined measurements, so there must be some kind of taper going on with these shims. I've got 108.5 thousandths on the top shim, and I got 105.5 on the bottom one. Remember that it's a bottom shim on the ring gear side that's responsible for spacing the ring gear with the pinion gear. It's the top shim that's responsible for achieving your bearing preload. If you approach it this way whenever you're making adjustments to your shim sizes, you'll achieve more consistent results. So 105.5 thousandths is my base shim, and that's about 4 thousandths smaller from where we just came from when the backlash measurement was too tight. The preload has also changed here because now it's based off of a measurement and a complete shim kit, and because it stretches the case to achieve that preload, that actually does affect where the ring and pinion line up a little bit as well. And it looks like the shim that's 108.5 thousandths needs to come down in size a bit because even with the case spreader, I can't get the diff back in there. I said earlier, if you can't get it back in there with the case spreader, your shims are too big, and I'm going to take my own advice here. The math says my preload's right, but I believe that effect's caused by these shims not being truly flat. And if that's the case, other people than me are certainly going to encounter this too, where their combined thickness and individual thicknesses don't add up. You only get shims in 2,000th increments, so if you get 5 thousandths of preload out of your stack, then the only result you can achieve to correct it is 3. I have to torque the pinion nut, and I tried to do this the same way I successfully did it with my Gallant differential, stubbornly, with the wrong brand new tool. It worked that time, but I didn't have any luck with it today. I'm still just as stubborn though. I figure I can just take it apart and bolt it to the flange, give it an extra bolt as a stopper, and not risk injuring myself this time. Every time I destroy some kind of thing to do something more important, I hear my beloved grandmother saying, "I can't give y'all anything nice, y'all just tear it up." I can put this one right back together, Grandma. The service manual says 136 foot-pounds, and that's quite a load. That's got to be torqued in order for any of my measurements to be meaningful, though. And before I torqued that pinion shaft, I'd snugged all the carrier bolts in place, but those need to be torqued too, 36 foot-pounds, and let's check out how these shims really fit. I'll just save you all the time of editing and narrating a longer scene here and tell you that I'm now at 5.5 to 7.5 thousandths backlash, which is too big. That's a 4 thousandths difference in shims along with slightly less preload, and that seems to have moved it about 3 thousandths of an inch away from where I was, not 2. So my math didn't math. My solution for this is just to tear it all back down and try again. Each time I do this, I end up another verifiable step closer towards my backlash and preload specs being right with the shims that I have. I felt this overhaul was a necessary example because I'm not just disassembling and reassembling good parts to make them pretty this time. If you have to fit new parts or different parts inside of existing ones, then this is why I wanted to show you that it's important to make a tool to help you do this easily. You're gonna have to do it a lot. None of these fixtures that Mitsubishi has in the service manual are available, but even if they were, the hammer handle method that they suggest is still stupid. So I've taken the 105.5 thousandths and substituted it with a 103. I'm taking the 107 off the bottom and I'm replacing it with a 109. To maintain my preload but change the differential center line, I had to adjust both shim sizes by 2 thousandths respectively, and now let's see how all this lines up. 4.5. Let me get you in here a little closer because there's something kind of hard to see going on here. The Lucas oil is slippery, but it's sticky. That's why you see it wandering around. I have to hold the pinion flange still because that's 4.5 thousandths of backlash right there. Only 3/10,000ths of an inch from where this ring gear and pinion gear lined up in the other case, but you measure multiple spots, not just one, and here I've got 4.5 thousandths. Again, that angle isn't perfect. Let me give you a better one. Okay, here we got 5.5 thousandths. Keep going. Over here it looks like just a tad under 4.5 thou. Five. Yeah, 5. It's hard to hold this thing still. Sticky. 4.5. 4.5. 5.5 thou. Another spot with 5.5 thou. This was precisely and exactly where I wanted to be on my Backlash spec. I can't be more happy with it. This is a huge accomplishment for this ring gear swap, and now that I've got my Backlash exactly where I want it, I want to focus on the rest of the fit, starting with the runout. You recall I applied thread locker to these bolts, set the ring gear in one of 8 possible positions, and I crossed my fingers. I say it like that because if either differential or ring gear had any warpage or any imperfections, then it would have worn into the other parts by now, and transferring one ring gear to the other differential can introduce runout. You can see here I've got a little over 3/1000ths of an inch of runout. Maximum spec is 2. This one would be noisy, so I'm marking my highest and lowest spots on the ring gear and on the differential so that I can keep tabs on where they are. Dry erase markers are a terrible choice for this, but it's what I've got right now. And of course, next is to take it all back apart again. You see what I mean? I want to know what Japanese hammer handles are made from. Additionally, I want to know what engineering was involved on the ends of their handles that prevent them from shredding under pressure of 4/1000ths of preload flex on a cast iron case. Is it fire-hardened hardwood? Walrus tusk? Whalebone? Why does it work for them? I just rock hanma pisoto, that's all. So I guess I gotta compensate for it with engineering. The thread locker always makes a mess, and it's a big mess to clean up on the ring gear and the bolts each time you get this wrong. That whole deal with measuring high and low spots here is an attempt to avoid having to keep doing this over and over again. Matching up the previous high spot on the diff with the low spot on the ring gear is the most scientific starting point in my imagination. The thread locker is part of the torque sequence every single time because it affects the torque load on the bolts. Each time I get it wrong, I'm going to have to do the same kind of cleanup with the razor blade, scraping vigorously, using solvents, compressed air, cleaning out all the bolt holes with thread chasers or a tap. I prefer using a thread chase. I use them both on the bolts and the ring gear, but both surfaces must be free of debris on a surgical level before you use the correct thread locker, which is a liquid and not a paste. That may have contributed to my problem because I did have to scrape some of that away that got stuck between the parts, and I did have to clean it off of both parts. Both parts must be razor blade clean before you do this. And using the right thread locker this time, fill each one of the bolt holes halfway with the thread locker goo, and then remember that you forgot to clean up all the bolts and go into full scramble mode for a second with rags and solvents and thread chasers. Now, hand tighten all the bolts in opposing plus pattern. Do the first 4 bolts, then the other 4 in between them, and then go back over them with the star pattern. And now you can grab the torque wrench, a 14mm socket, and set it for 58 foot-pounds. The last time I tried to torque this, I ran out of memory card, but deep down inside I always knew I was going to be back. I'll show you the trick that I use to hold the diff still with a rag in the vise. First, I do a star pattern torque sequence at 20 pounds, then 40 pounds, so that nothing gets pulled out of whack. You want to sneak up on this one. When you go for the final spec, take your brass punch and jam it in the hole in the front of the vise jaw there in the diff casing while you clamp it back down. Now it's obstructed by a softer metal so that it can't turn, and between the rag and the brass punch, you're not leaving a mark on it. That's what I missed showing you last time. You want to slowly creep up on your torque spec, increasing until you hit it, then hold it there. This accelerated video is saving you a whole lot of time right now because there's 8 bolts, but if you notice that gradual lean, I'm spending several seconds on each foot-pound increase until I hit that spec. This is at 4x speed. And this is it at normal speed. The right thread locker is what's built into your torque spec. Just because you reach spec doesn't mean the bolt's done turning. If you're using a digital torque wrench, you got to hit the spec and hold it there for a sec. If you do that on all of them, they're going to be very evenly torqued. Now, just put all this stuff back together for like the 20th time, and I'll spare you all the details, except to remind you that the carrier caps get 36 pounds again. Oops, one got 27, oh well. And now to get set up again so that I can check my work. Going for runout spec, better than 3/1000ths this time. I'm struggling a little bit making adjustments off camera, trying to get this thing to stop drifting, but now, there we go. Go the other way with it. Oh, baby. That was a great educated guess for clock position. There's a 0.5 run out at best now. Looks like even less. That's dang near perfect. And when this is right, this is another reason why you include the thread locker in your torque sequence every time. Because now it's done. Now to fully go back over and check all my work, we had 4.5 to 6.8 thousandths on the backlash test before I fixed the run out. It's going to be interesting to see what I have now. That was 5.8, almost 6. Looks like we got another 5.8. That's good. Next up, looks like 5.5. Another 5.5. And it keeps drifting because of the sticky lube. I'm trying to hold that pinion gear as best as I can. 5 thou. That one looks like 4.2. I'm going to go the other way with it. Yeah, 4.2. The shadow's not being very kind at all. Another 4 to 4.2. Few teeth over from it there. It looks like the tightest spot so far. This spot looks like the biggest one. Looks like a 6.5 or so. It keeps drifting. I'm going to try it again. 6.8 is what I'm giving it. Give it a good turn here. That's a 5. This last one's 5.5 or 6, but in all of these cases, none of them are tighter than it was previously set up with the open diff, and none of them are even 1/1000th over it. All the way around the ring gear, yeah, it's looking good. It's on the loose end of fresh factory spec now, just like the Gallant is. So I'm going to roll with this. So now it's time for the die test. Dry erase markers are what I have today. Again, they work well enough. I did the thing with the brass punch like the manual said to. See, I don't rebel against everything it tells me to do. And the final result isn't perfect, but it revealed one thing. The contact patch lines up with the visible wear on the gear teeth where I didn't mark them. Exactly. See the fat side of the contact patch? Look at it on the teeth that follow it. I'd prefer to see these to be a tad more towards the center, which means that now all the other factors are correct. It would involve moving that pinion gear slightly further away from that ring gear, and potentially having to adjust the side bearing shims again, but here on this other angle, it's really not so bad. The fat spot's pretty close to center. It's the same on all the unmarked areas as well. I think that's just from the way that it wore. Their ideal wear pattern would have been both marks lined up in the center, of course with the fat edges of the contact patch opposing each other, and with a brand new ring and pinion gear you shouldn't ever settle for anything less than that. But in my case it's the exact same carrier housing, ring and pinion gears. All I've done is match the pinion gear positioning using a different differential with brand new side bearings. I've restored its factory position. If there's any correction that I'm willing to do at this stage that would guarantee that my close enough to perfect on all factory specs diff stays together, it would be to set the pinion bearing. While it's torqued and assembled, you can easily get to the pinion gear with a brass punch. With the nut already torqued, the bearing's preloaded, and that helps for this, but give both sides of the pinion bearing a whack with a brass punch. If for any reason either pinion bearing race can shift, then it's going to loosen the pinion preload and your rear diff will get really noisy and groany real fast. This is a common occurrence after a differential rebuild, and that's what this addresses. So after you've set the bearings, blast the nut off and retorque it. This nut says 137 foot-pounds in the manual. It doesn't say to use thread locker, but I'm doing it. Don't bust my chops about it affecting the torque specs. I'm going to give it 143.3 foot-pounds and then test the preload with an inch-pound torque wrench. And there's several stages of test for pinion preload that I don't do if I didn't change any of it, but you're supposed to do this test without the oil sealed twice first. And here it is exactly at the spec that it's supposed to have, oiled with a new seal, 5 to 6 inch-pounds.
That's all you should see. Anything else would be wrong. Of course, skipping those other tests won't tell you what you did wrong, but this last one is the one that counts. Setting the pinion bearing is how you do this and not have it all loosen up on you right when you put it back in service. The thread locker didn't over torque it, and it didn't mess up my preload. That thing ain't going nowhere. It's time to seal up the case, and what else to use for that but Honda Bond? Just kidding. Thank you, Matt, for the offer, and a lot of you would have, been happy and snickering behind your screens if I did that, but I'm a loyalist who uses Tri-Bond, which is the Mitsubishi branded tube of the exact same thing. Honda parts are okay for the Elantra, but this one's for the purists. I'm the guy who does the 1/8" bead instead of spreading it around with my finger. This bothers some people. This isn't an oil pump gasket. 1/8" is the right amount to not have a ton of excess squish out of these things. You'll end up with a very tiny and manageable bit, but you won't get it all over you and everyone else doing it this way. Just leave no gaps and surround all the bolt holes. Next, just grab my bolts, which will get changed when it gets installed into the Volk metal craftery or subframe, but I needed them for setting the sealant up first, and I grabbed my torque wrench, set it to 24 foot-pounds, and torqued them all the way around. Make an extra pass because RTV is squishy. Done deal. I'm not going back in there for anything. I'm ready to move on from this one. Now, there's only 3 easy parts to install before this thing's all wrapped up. This is the stage of every job where you're always going to be in grave danger of something terrible going wrong, especially if you've managed to do the job without spilling a drop of your own blood. Oh man, I just did it. Don't start doing your victory lap early, because now's when you break off your plastic vent tube inside the diff cover and spend the next 2.5 hours trying to figure out how to cut the thick broken off plastic sleeve deep inside a 1/4" hole where pliers can't even grab, leaving you having to find a way to cut it, fish it out by one edge, and finally grab it with pliers to pull it the rest of the way out. Don't tell me I can't do anything. I totally will. That wouldn't have hurt anything because it stabs into a sealed compartment that can't drop chunks of anything inside the diff, but I'd always known it was there. I go through this extra effort because this one's mine, but anyway, put a 45-degree angle bead of Tri-Bond around the vent plug, jam it through the hole, and use a 12-point socket against the plastic part of the plug to drive it home. New shiny vent plug, yay! As you can witness right here, the amount of RTV that squished out was very minimal. There's nothing about this diff that can be blocked or suffer in any way from the excess of this tiny beads on the inside, so it's easy to clean up the outside quickly with a pick after it's been setting up for a few minutes. Same exact seal whether you're talking about 1G or 2G. MD707184. Best thing you can do to help yourself here is spit on it. But if you're lucky, you have the seal driver made for this thing. Miller tool part number MB991115 has the detent to protect the lip of the seal on it. It also has an outer flange that sets the seal depth correctly against the case. I'm lucky, and I know it, because now the diff's all finished up and ready for action. This is a big deal for this car because aside from the engine, this differential was on its way out. I'm grateful to share this experience of giving one of the good ones a new life, and I'm glad that I got to do more than just make it look nice because I know that that's more helpful to other people who are in this same boat with me. The seals, plugs, bearings, and shims can be found. They just take a long time to get to you. Estimate roughly a month if you're working on the same thing as I am. Hopefully my trick with the turnbuckle case spreader thing makes the lives of everyone who accepts this challenge a whole lot easier. This doesn't have to be hard, but there's a whole lot of repetition. You do have to be patient. It's worth having patience, and it's much easier when the thing you're building is awesome, even if it's ugly. I'm sorry this took so long, but I never got off my horse. Some of the places I wrote it don't belong in this video, but stick around because the journey's only getting better. Big updates coming to Patreon. Thank you, Mighty Legends. Until next time, stay tubed.
car. Now you're gonna have to pay for my car.